Write down polynomials. Now this is a unit where when people are here the whole time, they do really well on. It seems a little bit frustrating sometimes just because we have to learn regressions, which is quite a few steps, but we use regressions in polynomials, exponential, logs, and sinusoidal. So for the last 4 units, we do regressions on all of them. So at first it seems a little bit frustrating, but it's really, people by the end are like, I love regressions and I want more. No joke. By the end of the unit, they're like, they come back from the diploma and they're mad that there wasn't enough regressions on it because you're like, these are easy. So at first when you're frustrated with the steps, trust me, it gets easier and you guys actually, most people really like it. The only people who don't like regressions are the people who don't attend class and therefore don't learn the buttons and therefore it's miserable. Okay? So the first polynomial we're going to look at is we're going to look at y equals mx plus b. So this one you guys looked at in grade 10. It's a linear function. Yeah, you're going to be quiet and you're going to write this down. Y equals mx plus b. So, everyone who needs a calculator out. If you don't have a calculator, you need to move beside someone who does, and you need to be quiet when you move beside someone who does, or you can ask me for one. Because I'd rather you actually have one in your hands, because you need to learn. Let me grab you more. 1 second, I don't know, stop recording. Go into your Y1 and type in 3x plus 7, please. Into your Y1, type in 3x plus 7. X is the xt theta n button beside the alpha button. You can just go 3, and then you press the xt theta n button beside the alpha button below the mode button, and then plus 7. Now, what you can also do after this, please, is press zoom. Zoom is in the top middle. Zoom, then 6. Zoom 6 is your standard window. It'll reset your calculator all the time to -10, 10, -10, 10. That window without you having to type it in. So go zoom 6. Now we have a graph, right? It's linear. It's a line. Okay? Shh. Yeah, high tech. All right. So, yeah. So, we have this one. Now, it looks something like this. No, you don't have to draw it. You just need to, whoa, that's a really bad line. We'll pretend it's like that. So, y equals 3x plus 7. You need to write that down. You can do a little sketch if you really want to. But these are linear graphs. They all are lines, right? So take out the 3x plus 7 and type in this. That wouldn't be linear. Negative. So you're going to press the negative button by the enter into your y1. So take out your y1, clear it out. Now type in negative 2x minus 3. And you're fine with it's already reset. It's just if your calculator was wonky before. You don't have to press zoom 6 every time. Just press graph. Yeah. So this one has a y-intercept at -3. This one had a y-intercept at 7. And it has a slope down to right 1. So it looks something like this. What's the difference between the two? Yeah, you always look at them like you read a book. So it's from left to right. So from left to right, what's happening on this one? It's going up because it has a positive slope. And what's happening with this one? It's going down, right? Okay, so your leading coefficient tells you how it ends on the right. The leading coefficient is the number that leads the largest exponent. So in this case, the leading coefficient is +3, is it not? So our leading coefficient is positive. If it's positive, it ends up on the right. Okay? If it's positive, it ends up on the right. We see that? What about this leading coefficient? It's negative, and what are we ending? Down on the right. It tells you how it ends down on the right. Indirectly, then, it also tells you how it is on the left, correct? Because linears are just in opposite directions. So if this leading coefficient is positive and it ends up on the right, that means it started down on the left, right? Because they have to be in opposite directions, these linear lines. And this one, it ends down on the right, so it must have started up on the left, okay? Now, if they're in the equation form where there's no brackets in the equation, so in here there's no brackets, right? It's like mx plus b. If it's in that form, your constant, the constant is the one without a variable. Your constant is your y-intercept. So, this is the one without a variable. It's my y-intercept. So I have a y-intercept at 0, 7. Here, I have a y-intercept at 0 and -3. So right from these equations, you can tell me how you end up or down on the right and the left based on the leading coefficient, and you can tell me the y-intercept solely based on the constant at the back. It's constant because it doesn't have a variable with it, so it's going to remain constant. No matter what I fill in for x, that number will always stay the same because it doesn't have an x on it. It's a constant. That's where the word constant comes from. So, little notes for these. If you have a positive leading coefficient, it ends what on the right? Up on the right. And this does not change whether it's linear, quadratic, or cubic. It doesn't matter what polynomial I give you. If it has a positive leading coefficient, it ends up on the right. Okay? If I have a negative leading coefficient, it ends down on the right. And what did I tell you about the y-intercept? What is always the y-intercept? Starts with the C. The constant, yes. So the constant, so this is important for that. The constant is just the number without a variable. Is the y-intercept. And this only works if there's no brackets. All of these only work if the actual equation doesn't have brackets in it, if it's all expanded. Okay, if there's a bracket in it, this stuff goes right out the window. So in the case y equals mx plus b, your y-intercept would be 0 and b. And it's always 0 and the constant, because in order for it to be on the y-axis, which is the y-intercept, what does x have to be? 0. Okay, there's a few other things we have to go over with linear. So, with linear, we have to look at the domain and the range as well. Now remember, the domain and range, what I'm going to tell you, only works for whenever I give you an equation without it being a word problem. The moment it's a word problem, a lot of stuff gets restricted. For example, if it's a word problem and x is time, you can't have negative time, right? So your time would have to be greater than or equal to 0. So it's not always going to be whatever I tell you now if it's a word problem, okay? Now, for linear functions, it goes on forever and ever this way or this way, correct? So what can you tell me about the x values then? Are there any x values that don't exist? If it keeps going on forever, it's infinite. So my domain for linear is XER. X is an element of the reals. Okay? What's my range? My range are the y values. Greater than or less than what, though? Where does the y stop? Does the y stop going down? No. Does the y stop going up? It's infinite. So what would it be? Y is an element of the reals. Right? How many x-intercepts does this graph have? 1. Will it always only have 1? Yeah, because it's going to cross somewhere, right? So 1 x-intercept, always. Because it's going to have to cross it somewhere. We agree? If you have a textbook, I want you to open it up. We are going to open it up to page. We're going to do a few questions, and then we're going to go to quadratics. Then we're going to do a few questions, and we're going to go to cubics. So we're going to do these ones together. Okay. Shh. Quiet, please. I want you to look at page 287 for now. Page 287, number 1. So we're going to do the homework together. So we're on page 287, number 1. Number 1B. We're doing the homework together, so you're going to answer this. It says, determine the degree. Now, linear functions are degree what? What do you think? What's the largest exponent? It's y equals mx plus b. So the only variable I have here is x. What is x to the power of? 1. So it's a degree 1. Whatever your largest exponent is what the degree of your equation is. Okay? So if we look at b, b is g of x equals negative 2 over 3x plus 10. What's the largest exponent in this equation? It's a 1. So what degree is it, guys? 1. Okay? It then asks you for the leading coefficient. So it's degree 1. Yes. The leading coefficient in this case is the one that the coefficient that leads the equation. So it's always the number in front of the largest exponent. So even if I wrote this as 10 minus 2 over 3x, my leading coefficient wouldn't change because it's always the coefficient that leads the equation. So the one in front of the largest exponent. So in this case, my largest exponent is x to the 1. So the leading coefficient is negative 2 over 3. Okay? Then it wants the constant term. Remember, the constant term is the number without a variable. So what's the constant term, guys? 10. These 3 things, the reason why they ask for them is they tell you a ton about this graph without you having to type it into your calculator. And why would that matter? Because if they give you an equation that doesn't have numbers in it, that it's just all variables, and they ask you questions about it, you can't type it in your calculator and look at it. You need to know stuff just by the pieces of it. So degree 1 tells me I have a what type of function? Positive or negative. What kind of function is it? Degree 1. We just wrote it at the top. Someone said it. No. Linear. Degree 1 tells us we have a linear function. That's why they're asking you what the degree is. So it's either going to look like this, or it's going to look like this, because it's a linear function. That's what the degree tells us. Okay? That's why they asked us it. They didn't ask us it just to see if you knew. They asked us it because it's leading us into information. The next thing is the leading coefficient is negative 2/3. Why do we care about the leading coefficient? What does the leading coefficient tell us? The direction, how it ends. On the right. So the 2/3, does that tell me anything about how it ends on the right? No. The sign does. So my leading coefficient is negative. So it ends down on the so I know it looks something like this. Or it could look like this. But I do know that it ends down on the right at the very least. Correct? We also know then that it ends up on the left because we know our arrows are in opposite directions. Does that make sense? What is the constant term 10? Why the heck would they even ask us for that? Because it's our y-intercept. So they ask us these questions not to just give us questions in a textbook. They ask us these questions because it helps us be able to understand the graph, right? Because just punching it into your y equals and telling me what it looks like is not sufficient. So I want you to give me the degree, the leading coefficient, and the constant of f of x equals negative 2x minus 5. I want you to do the exact same thing I did here below this one. Okay, you try that. So what's the degree of this one? Degree 1, because it is what? Linear. What's my leading coefficient? Equals negative 2. What does that tell me? What does that indirectly tell me? Up on the left. Constant. Negative 5. What does that tell me? Close. Y-intercept. Okay? Looking back at our book, we're going to look at 3B. 3B has a graph like this, if you don't have your book in front of you. Okay? Without even reading the question, tell me stuff about this graph. Because this graph exists, tell me stuff about the equation. Sorry, is what I meant. What's positive? It's a degree of 1. It's a degree 1. We know that because it's linear. Okay, what else can you tell me about the equation? The y-intercept is 0, 2, which tells me what about the equation? The last part is 2. What's the last part? Another word for that? Constant. Positive what? What kind of coefficient? Leading coefficient. We can't just say constant, or we can't say coefficient because any number in front of a variable is a coefficient, right? So we have to say leading coefficient. So the leading coefficient is positive. Why? Up on the what? Yeah. So I can give you a graph and you can tell me tons of stuff about the equation, right? Number 5. Number 5 says, and we're going to look at 5e. 5e is q of x equals negative x minus 1. 5e is q of x equals negative x minus 1. Please be quiet. The question says, describe the end behavior of each polynomial function. So it wants the end behavior. What do you suppose end behavior might mean? Where it ends, how it ends, which quadrants, right? So this one has a negative leading coefficient. So where does it end on the right? Down on the right and then up on the left. Now if we looked at quadrants, quadrants on a Cartesian plane are 1. What am I doing? I'm doing cast from trig in 30-1. Shoop. So this is 1, 2, 3, 4. So we always go from left to right. So what quadrant do you suppose that one would start in? 2 and end in? Nope, because it's going to keep going on forever. So even though on your little screen, it might look like it's starting in 2 and ending in 3, starting in 2 and ending in 3 down here, eventually what's going to happen? It's going to keep going, keep going, keep going, keep going, and it's going to cross over into 4, right? Because it goes on forever. So your quadrants are either going to be 2 to 4 or 3 to 1. Those are going to be your options for linear. Because eventually it will get through those. You have to go 2 to 4. Because 4 to 2 just doesn't make mathematical sense. We always go left to right. Yeah. Okay. The next one we're going to do is you're going to look at number 6. So you need to look at your actual textbook. Number 6. We're only going to look at 6a and d. So you're looking at number 6 in your textbook or looking at someone's textbook beside you. And we're looking at 6a and d, the graphs a and d. You help me out, okay? So we're going to look at this. What is a way that, so we need to match some equations to graphs, correct? And 1 is a cubic function, it's an x cubed. So do we care about it right now? 2 is an x squared. Do we care about it right now? Which are the only 2 we care about right now? The last 2, right? Those linear ones? Now, if you want to compare graphs, so this is something I'm going to teach you. If you are given an equation or you find an equation and you want to see if it matches what graph on your test, the best thing you could do is when you put the equation into your y equals, change your window to match the actual window of the graph that you're looking at. Okay? So the graphs that we're looking at, what are their windows for the most part, for the linear ones? A and D. They go from -5 to 7 on the y, and they go -5 to 7 on the x, correct? So go to your window. So press window on your graph. I want it to match the exact graph, though. So you can, but the best way to do anything on the actual test is to change your window to be the exact window so it matches completely, not that you pick something because you think it matches. So your x minimum, if you look at those 2 graphs, what's the lowest your x goes to? -5. In the textbook, if you look at the graphs, they go -5 for x, so make your x min be -5, and your x max be 7. Then your scale, what do they go, x scale just means what they go up by. What do they go up by? Each tick. Each tick is 1, so we put 1. The numbers go up by 2, don't really care about that. I want to know what the little ticks go up by, right? Which is 1. Then my y minimum is -5. And my y maximum is 7. And what do they go up by? 1. Does the x min and the x max and the y min and the y max always have to be the same? No, they just happen to be the same in this instance. They don't have to be the same. Okay? Now, in your y1, put in 3 minus x. In your y1, put in 3 minus x, because that's one of the equations. Which one does it look exactly like? A. So you put in 3 minus x, and it matches A completely. Now, if you had your window at -10, 10, and -10, 10, you could say, yeah, I think it matches this. But if you make your window exactly the same, it will look exactly the same, and you can walk away going, okay, I didn't make an oopsie and pick the wrong one. Okay? You mean minus x plus 3? Yeah. Okay, and then in your y2, you would put in -2x plus 3. Or you could clear it out completely so you don't have 2 equations at once. But let's try having 2 equations at once so I can show you something. So everyone's paying attention because this is a little learning deal. So in y1, you have 3 minus x. Then arrow down, and in y2, please put in -2x plus 3. So in y2, you now have -2x plus 3. Does everyone have 2 equations? Don't press graph. You just have 2 equations. Okay, we'll go back to y equals. So when you press, don't do this, but when you press graph, it draws them in order, correct? However, you look away and you look back and you're like, oh goodness, which one was which, right? After that, you don't know. So the way you can know is go to your y equals, so you should still be in your y equals. Go to your y2, please. Go to your y2 and arrow left until you are on the slash. So arrow left until you are on the slash. That slash on the other side of the y equals, okay? Are you on the slash? Hit enter once. Now pay attention. If you are someone in this class who's going to hit enter 700 times to see how many different ways you can change. Don't waste your time. There are only 2 that you want to use. I know at this point, what happens is I'm going to lose a few of you to trying to push all the different things and see what it does. One of them shades above. One of them shades below. One gives dots. One's a dash line. Yay, hurrah. Okay, we went through all of them. We now feel so much better about ourselves that we've tried them all out. We now need to pay attention to Mrs. Lepp. Okay. So make sure you have the thick line now, right? Now what happens is, it's a light, yeah, he is very excited. Okay. So now I always make the y2 be the thicker line so that I always know that the y2 is the thicker line. I don't switch them out. Now press graph and it'll draw the y1 as the normal line and the y2 is the thicker line, and then it'll draw them in order. But now when you look away and you look back, you have never been this excited in your entire life. You have the y2 is thicker, okay? It's not a speaker. It's like dot lines. There's joy to other children around from getting toys and food. But I can just show a thicker line and life is good. They all know it. But okay. So it's great. All right. I want you guys... Shh. I want you guys to do number 7A, please, on your own. Number 7A. And 7A, you have about 3 minutes, and then we're moving on to quadratics. They don't say that. You said that. 7A. Down. Quadratic functions. The good thing about polynomials is all of the information that you use, like leading coefficient, y-intercepts because of the constant, all that stuff, whether it's linear, quadratic, or cubic, they all follow the same thing. So we're looking at the function y equals ax squared plus bx plus c. And remember, if there are brackets, you have to expand it first to get rid of those brackets, okay? Before you can use any information. So, if I have a positive leading coefficient, what did you guys tell me about that last time? It ended up on the right, okay? And if it was linear, it ended down on the left, because linear is just a line. But quadratics actually make parabolas, correct? That parabola, that U shape, or the upside down U shape. So if I have a positive leading coefficient, it ends up on the right, but it also ends up on the left. So it still follows, it still follows the same rule where it's up on the right. It's just because it's a quadratic, you must know that it also is up on the left then too. Okay? If you have a negative leading coefficient, how would it end?
It would be the other way.
Down on the right, but it would also then be down on the left, like a rainbow. Okay? The constant is still the same thing. What was the constant on a linear? The y-intercept. What's the constant on a quadratic? The y-intercept. It doesn't change. Okay? It doesn't change. So, from your equation, you can give the end behavior. You can give me the domain. You can give me the y-intercept. But you are going to need your calculators to give me the y-intercept and, no, sorry, not the y-intercept, the y, so the range, and the x-intercept. Yeah, exactly. So, what's the domain of every quadratic?
XER.
XER, because it keeps going on for forever. So this one is XER, and this one is XER. It doesn't matter if it's concave up or concave down. The domain is XER. But you're right. The range changes. Yeah. So the range of linear graphs is YER, right? But quadratics, they stop. The Y doesn't keep going on forever because the arrows aren't in opposite directions, right? The arrows are in the same direction. So in this case, for my range, this is the lowest or the highest it can go. The lowest it can go. So it's going to be that or more. That or more means greater. So what we would have, our range is going to be Y such that Y is greater than or equal to the minimum. And we'll have to find that using our calculator. And we'll do that in 2 seconds here. And then this one is the highest it goes or less. Right. So this one's going to be Y such that Y is less than or equal to the max. YER. Okay? All right. So we're going to go through some examples. So for the first one where it's concave up, I know that I have to give you an example with a positive coefficient. So I'm going to give you y equals x squared minus 3x plus 2. So type that into your y equals, please. y equals x squared minus 3x plus 2. Once you have it typed in, make sure you clear out the other ones that you have in from linear. So press graph. Okay, so is this a minimum or a maximum? It's a minimum. Because it's the lowest you can go, you can't go any lower, right? Now, in our calculator, we want to calculate stuff. We want to calculate the minimum, because if we know the minimum, then we can say y is greater than or equal to whatever the heck that is. So I want to find the minimum, which means I want to calculate something. If I want to calculate something, which is what I'm going to always want to do, I'm going to press second trace, because what's the word behind trace on the calculator? It's calculate. So that's what we're doing. So we're going to press second trace, which is right beside graph. Now you get a list that pops up, right? That list says value, 0, minimum, maximum, intersect, and then some good old calculus, which we don't ever need, 6 or 7. So we're going to pick which version, which number? Minimum. We're going to pick 3. Now we're going to listen to what our calculator says. Our calculator says what at the bottom? Left bound. So I need to be left bound of whatever the heck I'm finding. And what am I finding? The minimum, right? So I need to be on the left of the minimum, anywhere on the left. You could be close to it, you could be way up from it, right? But you need to be on the left of it. Then hit enter when you're on the left of it. Then it says right bound. So now you need to be on the right of the minimum. So you arrow over to the right-hand side of it. You can be just so over it or you can be way up. It doesn't matter, but you need to be on the right-hand side of the minimum. Then you hit enter. And then what does it say? It says guess, and that makes you hit enter for it to figure it out. I don't know why. But anyways, hit enter. And it gives you 2 values. It gives you the x is 1.5. Is that actually how low it goes? No, that's where it occurs. So this graph occurs, the minimum occurs over at 1.5. But what's as low as it actually goes to? Negative 0.25, correct? So the range of this graph is y such that y is greater than or equal to negative 0.25 YER. Okay? We agree? And it's greater than or equal to the lowest it goes. And whether you were in 20-2 or 20-1, you learned this. It may not be fresh in your head. You may not remember it, but you learned it. Yeah. To find the y-intercept? Yeah. But remember, way off the equation here, we can tell the y-intercept, so you don't even have to do that. You pick minimum.
Like in window?
No, you press second trace. Minimum. Okay. Now, I want you to tell me the end behavior of this graph. End behavior is the quadrants. So, the leading coefficient tells me the end behavior, right? This is a positive leading coefficient, so it ends up on the right and it ends up on the left. What quadrants would that be in? Goes from 2 to 1. So from quadrant 2 to 1. What's the y-intercept? You don't need your calculator. You don't need your calculator. Your y-intercept is 0, 2. Y. What does your calculator tell you? 0, 2. But from your equation, it's always the what? The last number of the constant. So 0, 2.
Let's be honest. I was just double checking.
Okay. Now, x-intercepts. You can do second trace 0, or there's an easier way I find that most people find better. So y1 has your equation. What was the equation? X squared minus 3x plus 2. We agree? When you're finding x-intercepts, or when you're finding y-intercepts, x equals 0. That's what you did, right? When you're finding x-intercepts, what equals 0? Y. So this is what I would recommend you do. It's a little bit easier than the left bound, right bound, but if you want to do the left bound, right bound, second trace 0, left bound, right bound, fine. I am not going to tell you you're wrong, because that's completely correct. But this is another way you can find the x-intercept. So in y2, you'll put 0. And I would make it thicker. Because if you don't make it thicker, you're actually not going to see that it draws itself over the x-axis. Okay? Because it's the same thickness as the x-axis and you won't see it. It touches in 2 spots. Yep. So, yeah. Yep. It does. So, what you can do if you want to see if you want to see it better, you can shrink your window so you can see it better, right? So I would make my y min be -1. So go to your window and make your y min be -1 instead of negative whatever you have it at now. How many times does it cross? Yeah. How many times does it cross the x? 2. They're really close together. If you still can't see it very well, shrink your x's. So make your y or your x min be -4 and your x max be 4. If you shrink your window, you can start seeing it better. Right? Now, if you do this to find out, they look like 1 and 2, but to guarantee that they actually are 1 and 2, you have y1 be this and y2 be 0. Now you have 2 lines. When you have 2 graphs, not 2 lines, actually, you have a parabola and a line. But when you have 2 graphs, what can you always calculate? Where they intersect. You're right. So now that you have your 2 graphs, you can just go second, trace, which one? Intersect. So if you go second, trace, number 5, which is intersect, and then enter 3 times, you'll get one of them. Which one is the one that you get? You could either get 1, 0, or 2, 0. Either way, I got 1, 0. You have to do it again to get the other one. So you'll go second, trace, 5. But if you just go and hit enter, enter, enter again, it'll keep finding that same one. You have to move closer to the other one. So move over closer to the other one and go enter, enter, enter. And then you get 2, 0. Okay? Now, you guys told me with linear lines, so with degree 1, that I would have one x-intercept, right? Always. A degree 1 function will cross the x-axis once, for sure. Correct? Degree 2, so quadratics, can have 2. We just found 2, right? So number of x-intercepts. You can have it where it crosses through twice. So you'd have 2. Or what's another option? It could run tangent with it. It could come up, touch it once, and then bounce back down. And then you would have 1. So people have given me those options. They said you can have 2 x-intercepts with a quadratic, or you can have 1 x-intercept with a quadratic. Are there any other options? No x-intercepts. What would have to happen in order for that to happen? It either stays up top or it goes below. So it's either way up here, or you could have a concave down one that never touches it, right? So 0 x-intercepts. Yeah. Yeah. So I'm going to write down the questions I want you guys to work on. Still have to work on it. You use it every day, yeah.